Yo, let me tell you about biological countermeasures to mitigate radiation exposure. Okay, did you know that one of the limitations of humans traveling or living in space is the radiation exposure that you're gonna get on a daily basis? Let me tell you about it, or let me tell you my journey. First off is I wrote a paper last year, here it is, and it kind of outlines the genetically engineering aspect of a mesenchymal stem cell or stromal cell to overexpress this thing called SOD3 or extracellular superoxide dismutase, which will bind, free radicals, reduce ROS species, etc. All right, so the idea is that it would be used as a therapeutic agent for, astronauts or space travelers, and then be able to protect or condition until you made it to some shielding apparatus on whatever planet that you're looking to inhabit it, or maybe Mars. Okay, so with that, there's a lot to do, right? So first, it's the engineering of the cells for the overexpression and all of that. That brings to the next step, which is I participated in Humans in Space Challenge. In that challenge, I won the first round because, it's a fucking epic idea. But it needs some maturation. Now, the last part is that, how do you test a radiation environment here on Earth without nuking a bunch of animals unnecessarily? I love the animals. Or the organ on a chip, it doesn't generalize to humans very well. What I choose to do is simulate it. So then that brings to GUML. GUML is a molecular dynamics engine I built in Rust, which you've heard me talk about before, and that's simulating it. So it'll simulate a radiation environment, and a byproduct of that is also simulating a oxidative stress environment. And so it's going to have to require high throughput testing when you're doing the wet lab and everything. So prior to that, you got to simulate it. So simulate it and visualize it. You can learn a lot. So that's where it's at right now. And so biological countermeasures, it's a thing. Peace.